Hello and welcome to Calculus Lesson 31. Today we are talking all about the product rule. For about the first half of this school year, we are going to be talking about different ways to take the derivative and different tricks that will help you do it faster. For the second half, we'll be undoing the derivative with integrals. But today's lesson is about how to take the derivative of a product. So what does product mean? Well, that means you have some f of x times some other function, g of x, right? Product means multiplied. You're trying to take the derivative. Now, we're going to write this a little simpler, fg of x, and we want the derivative of that. The derivative is actually really simple, but anytime you have a product, you have to make sure that you do this. It's quite easy to forget. So you take the derivative of the first times the unchanged second function plus the derivative of the second function times the unchanged first. So suppose we have x squared sine of x, and we want to find the derivative. Our first function is x squared, or f in this case. So I'm going to take the derivative of x squared, which would be 2x. I'm going to leave the second function unchanged. Then I'm going to leave my first function unchanged and change the second one. And that's the derivative. That's it. Derivative of the first times unchanged second times the derivative of the second times unchanged first. Bingo. Let's try another one. We have x squared e to the x. They're liking those x squareds. So derivative of the first would be 2x. Derivative of the second would be e to the x times unchanged first. So that's your derivative of x squared e to the x. It's pretty simple. But as part of calculus, and as part of any good mathematical study, we also want to look at the proofs for these things. Just like you should go about your work about your salvation with like fear and trembling, you really need to be serious about whether or not what you believe in is true, right? The fact that we love Jesus, the fact that he died for us, like, do you believe that, or are you just saying that to get by? Like, work that out. Struggle with that. Wrestle with that. Make sure that you know that your salvation is assured, that you know the real Jesus, that you have a relationship with him. So here, I'm going to prove this out for you because it's not enough just to say this is the right answer. So how would we go about a proof of fg of x prime? Well, anytime we're taking the derivative, we're likely to use the definition of the derivative. So fg prime is the limit as h approaches 0 of fg of x plus h minus fg of x. I'm all over the place with my notation today. Sorry, guys. Over h. Well, that's gross. So let's expand this guy out a little bit. This is the limit as h approaches 0 of f of x plus h, g of x plus h, right? Just multiply together, minus f of x, g of x, all over h. Gross? Yeah. Now, I'm going to do some hand waving. So watch out. It's going to come and go like that. Okay? The way we get this limit to work out is that we add this super special term. And that is the following. We have f of x plus h, g of x plus h. Then I'm going to subtract, watch this, this is crazy. Actually, I'm going to add. Do I want to add? The book does this backwards of the way I like it to, but I'm going to do it backwards for your benefit, and then I'll show you why I don't like the way they did it. So I'm adding this random term in the middle, and you'll see why we add it in a second. But if I add it, I also have to if I subtract it, I also have to add it. Minus f of x, g of x. So we have this ugliness, right? But hidden within this ugliness is actually a pretty cool trick. So if I factor out f of x plus h here, then I am left with the following. G of x plus h minus g of x over h. Okay? Now I'm going to take this limit. So plus, remember this will still be over h, even though I'm splitting these into two fractions, that side and this side. That's all right. So I have the limit as h approaches 0, and I'm going to factor out g of x here. I have f of x plus h minus f of x over h. Now, here's where the fun comes in. Are you ready? I'm going to plug in 0 for this only. So I'm going to plug in 0 for this term, and then I'm going to leave this term in the limit. So if I plug in 0, I get f of x times the limit as h approaches 0 of that. Okay? If I plug in 0 here, nothing happens. So I can just move these around freely. Again, this proof is a little hand wavy on this part, but it does end up working in the end. So, what now? Now I have f of x times g prime of x, right? This is just the definition of the derivative in g, plus g of x times f prime of x. So, does this match what I gave you up there, right here? No, they switched the terms. But, alas, the product rule does work. And so I would encourage you to memorize this guy right here and add it to your equation sheet. That, my friends, is problem set 31.